lines and magnetic fields. So the magnetic south pole of the earth is in Canada. Before that, I want to say something. So if this is planet earth, then we know if I take a piece of magnet and if I tie it to a string, then the north pole of the magnet will point towards the geographic north of the earth, and the south pole of the magnet will point to the geographic south of the earth. Now, the earth has a geographic north and a geographic south. The earth is also a magnet, so the earth will also have a magnetic north and a magnetic south. So the magnet points towards the, so if I take a piece of magnet, this is the north pole, this is the south pole. It points to the, if I tie it to a thread, I suspend it in the air, the north pole points towards the geographic north and the south pole points towards the geographic south. But the north pole points towards the magnetic south of the earth, and so I'm just going to say magnetic south, and the south pole points towards the magnetic north of the earth. Okay, so not completely in line, but somewhere towards that. So that means earth is also a huge magnet, and the magnetic, obviously we know unlike poles attract each other, so the magnet has this north pole, it will attract or it will go in the direction of the magnetic south pole of the earth, and the south pole of this magnet will go towards the magnetic north pole of the earth. Okay,
But ma'am, why is it so? Why can't it just turn into the geographical north? And but the geographical north, that means the geographical north is magnetic south, and the geographical south is a magnetic north.
correct, yes, except a tiny change. I will explain that later on, but more or less you are right. Uh, what is that change? When we read this, you'll understand. Okay, so the magnetic south pole of the earth. Now, do you know where the north pole is and where the south pole is? What is on the south pole of the earth? Like which region? Like we come on the equator, right?
Antarctic region, ma'am. Antarctic region. And
Antarctic.
on the north,
Yes.
and
So
on the
Antarctic.
north is the Arctic region.
Yes. So South Pole has the Antarctic region and the North Pole has the Arctic region, right? So now what they are saying is, if you read the sentence over here, the magnetic South Pole of the Earth is in Canada. Okay, where is Canada? Is it in the northern hemisphere or in the southern hemisphere?
Ma'am, it's in North America. So, ma'am, it's in the northern hemisphere.
Very good. Yes. So it is in the northern hemisphere. That means it's closer to the North Pole, right? So the sentence is saying the magnetic South Pole of the Earth is in Canada. So that means the magnetic South Pole of the Earth is closer to the North Pole, the geographic North Pole of the Earth. Okay. And so it is in Canada at a distance of 2,240 kilometers from the geographic North Pole at an angle of 70 to 75 degrees north latitude and, at this particular point, 70 to 75 degrees north latitude and 96 degrees west longitude. So you guys know what latitude and longitude are?
Yeah, ma'am, we studied and Suchit studied.
Right. So at that particular point in Canada is where you have the magnetic South Pole. So while the Earth's magnetic North Pole is at a distance, same distance, 2240, from the geographic South Pole at 73 degrees south latitude and 155 degrees east latitude. You don't have to remember all these numbers, it doesn't matter. All that matters is you know that the geographic north and geographic south is different from the magnetic south and magnetic north. And they are not on the same axis. The magnetic south is 2,240 kilometers away from the North Pole, and the magnetic North Pole is 2,240 kilometers away from the geographic South Pole. Okay, so that is why I did not draw them in the same line. I drew them slightly away from each other. This distance is
Ma'am, can you please draw like the if the axis of geographic north and south?
yeah. So if this is the axis of the geographic north and south, then this will be the axis of magnetic north and south.
Ma'am, it will be slightly in 20 to 30 like in degree when we are looking in max and or in with compass we are with protractor we are if we are looking it's like slightly like that.
Okay, so actually I have exaggerated in this drawing so that you can see, but actually it is approximately, if you look at the last paragraph over here, it will tell you the angle between magnetic axis and the geographic axis is known as declination. Okay, so this is known as declination, which is approximately equal to 17 degrees. No, don't look at the paragraph. I'm asking you, like, just generally, did you understand the north-south axis, geographical north-south axis?
Yeah, ma'am, I understood.
Okay. Now, did you understand the magnetic north-south axis? Okay. Now, if I draw these two axes and I measure the angle between these two axes.
Can I say something?
Yes.
Ma'am, in the first paragraph, I think like the last line of the first paragraph, you have written latitude spelling wrong. I think it's not
Yeah.
a double T.
Yeah, it's not double T, it's a single T. So I copied this from the reading material and I did not change the spelling. But yeah, you're right. Okay. So this angle is called as declination.
Ma'am, I'm asking you that which angle are you telling about the difference between the geographic North Pole axis and the magnetic North Pole axis?
Yes, I am
That
talking
is
about the difference. Yes. Now, the magnetic field lines of the Earth are normal to the surface near the magnetic poles. What does that mean? So, if this is planet Earth and these are my magnetic poles, okay? So, this is magnetic South Pole and this is magnetic North Pole. So what it's saying is the magnetic field lines of Earth are normal to the Earth's surface near the magnetic North Pole. What is the meaning of normal?
means usual. Usual, ma'am. Is it?
Do you guys know what perpendicular means?
Yeah, ma'am. Perpendicular. You have taught us that in like one axis, which axis? Okay. Yeah, equatorial line. You have taught us about that.
Yes. Yes.
Ma'am, you were telling something about the axis of geographical north and south and magnetic properties,
Yes.
right?
Yes.
So I missed that. Can you repeat it? I got disconnected.
So I was saying the magnetic north and south is different from the geographic north and south, and the difference between the axis or the angle between the two axes is 17 degrees, and that is known as declination. All right. So now let us look at the magnetic field lines. I told you that Earth is nothing but a huge magnet. So the Earth has its own magnetic north and magnetic south. So the magnetic field lines, they'll come out of the North Pole and they will go towards the South Pole. Okay. Similarly, they'll come out of the North Pole and they'll go towards the South Pole in the other direction also. So it's like a fountain. Okay, so this fountain is like the source of the fountain is on the North Pole. So this fountain releases this magnetic field lines from the North Pole, and then these magnetic field lines end up.
Excuse me, ma'am. I was not able to hear you. Can you please tell?
Yeah, so I was saying the magnetic field lines come out from the North Pole. It's kind of like a fountain. What happens in a water fountain? The water it emerges from the fountain and it spreads in all different directions.
Like rain.
Sorry?
Like rain.
Like rain, yes, but it emerges from one point, it goes upwards and then falls down, right?
Yeah, that
Yeah.
I didn't tell it in that method, but it is falling down and like rain.
Yes, that's right. So similarly, in a magnet, what happens? The magnetic field lines, they come out like a fountain from the north pole of the magnet. They come out and then they go around, they go on top and then they come down again towards the south pole of the magnet. Okay. So that is why when I look at this drawing over here, we'll notice that at the poles, if this is my pole, then this field lines are perpendicular, right? They are at 90 degrees angle, right? Right. So these field lines at this point, they are at 90 degrees angle. Similarly, at the south pole, when the magnetic field lines are coming into the south pole, they are again at 90 degrees angle. They are coming in. So at the poles, the magnetic field lines are normal to the Earth's surface. Normal means perpendicular. Perpendicular means 90 degrees. Okay. So the magnetic field lines of Earth are normal to the Earth's surface near the magnetic poles.
Ma'am, I didn't understand.
Okay. So, okay, I have a water fountain. Okay. Water comes out of this fountain and it falls down. Water comes out of this fountain and it falls down. Falls down, comes out and falls down. Clear?
Yes, ma'am.
Okay. Now, what is the angle between the surface of the Earth and at this point of the water?
It's 90 degrees.
It's 90 degrees. Now, if I tell you that this water goes around like this and comes to the other side like this.
Yeah.
Okay. And if it comes to the other side like this, then what is this angle with the surface?
90 degrees.
90 degrees. Exactly. Same thing even with a magnet, right? So if I tell you that I have a magnet, okay, if I say this is my magnet and the magnetic field lines come like this and they go like this, they come like this and they go like this, then what is this angle?
That's 90 degrees.
Very good. So what is this angle?
90.
90 degrees. So at the poles, at the north and south poles, the angle is 90 degrees, right?
Yeah.
Now, what about in this region? If this is my surface and this is the magnetic field line, this is the equatorial line, correct?
Yeah.
Yeah. So at the equator, how is the magnetic field line to the surface of the magnet? Do you guys know what parallel?
Ma'am, can you show me another example? Not like about the you have told. Like I understood everything, but the second thing you told about the like parallel, I didn't understand it.
Okay, that is fine. Did you understand perpendicular?
Yeah.
Okay. So at the poles, the magnetic field lines are perpendicular to the magnet. Okay. But at the equator, the magnetic field lines are parallel to the magnet. Why? Because what is happening to these magnetic field lines? They are coming out at 90 degrees, but while going towards the south pole, they are parallel to this magnet, right? So that is why it's not 90 degrees. At this point, at the equatorial line, they are parallel. They are not at an angle.
Yes, I understand, ma'am.
Understood?
Yeah.
Okay, so that is what this is saying. So the magnetic field lines of the Earth are normal to the Earth's surface near the magnetic poles and parallel to the Earth's surface near the magnetic equator. Same thing. Did you understand?
Yeah.
Okay. So in India, the magnetic equator passes through Thamba. So this region. So I'm not sure where exactly.
Is it Tumba?
Yeah, where is that? Do you know?
I think in Kerala there is one research center, rocket science research center, and its name is Tumba.
Maybe. Let me see. I'm not sure.
Like
Yes, it is in Thiruvananthapuram.
Yeah, ma'am. I think it's the same thing. I think about the rocket and all in Kerala. It's the main center about rocket.
Okay, cool. All right, thank you for sharing. Okay, I did not know that. So yeah, so this is in Kerala. So the magnetic,
Ma'am, it's like ISRO.
yeah, right. Okay. So yeah, so the magnetic equator passes through, how do you pronounce it?
Tumba.
Tumba. Okay. So the magnetic equator passes through Tumba. The line joining the geographic north and the geographic south is known as the geographic axis. We already know that. The line joining the magnetic north and the magnetic south is known as the magnetic axis. We know that as well. So yeah, we've already seen that the angle between both these axes is 17 degrees and it's known as declination. And the magnetic effect of the earth extends up to 5.28 into 10 to the power 5 kilometers above the earth. So what does that mean? It means if I have, if this is my earth, if this is earth, then the magnetic field, the magnetic effect of the earth extends up to 5.28. That means this magnetic field, if this is the magnetic field of the earth, then it extends up to 5.28. Then this
Ma'am,
distance
this
will be
5.28 is meter or something like that.
kilometers.
Okay.
Okay, 5.28 into 10 to the power 5 kilometers distance. Okay, so that much distance is how much the magnetic effect of the earth extends up to.